Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over properties of logarithms. We're going to be focusing on change of base and how to rewrite logarithmic expressions. All right, let's take a look at the instructions for the examples that we're going to be working on. So in this set of problems we're going to rewrite the given log expressions as a ratio of, first of all, common log, and then secondly as a natural log. Okay, let's take a look at the first problem, number 1. Let's say we have log base 3 of x. So we'll start by writing it as part A ratio of common log. Okay, common log. Now, what base does common log refer to? If you're talking about common log, you have to remember that that is log base 10. Okay, so the goal for problem 1 is to write log base 3 of x as log base 10. So all you just do, you just write log base, the target base, which is 10, in the numerator and in the denominator. Now the logarithmic argument, which is x, goes into the numerator position, and the base of your log goes into the denominator. Alright, so don't forget, the log argument goes on top and the base goes in the denominator. Alright, so there goes your common log form. Now one thing you want to remember is that when you write log base 10, it's customary in the mathematical community to omit the specification of that base. Alright, so you have log, this becomes log of x divided by log of 3. So whenever it's base 10, you do not need to specify what the base is. Alright, let's go ahead and rewrite the same problem in base common log, using natural log. So the B part, we want to write the given log as a ratio of natural log. Okay, so what base does natural log refer to? If you're dealing with natural log, that is log base e. Okay? Alright, let's go ahead and try the problem. So we have log base 3 of x. And then now you're going to write this as log base e of the logarithmic argument x divided by log base e of the base, which is 3. So this is the application of something called the change of base formula. Okay? Alright, so we have that down. And then log base e is written as ln, natural log of x, divided by ln of 3. So just like how you don't specify the base for base 10, when you have base e, the natural number e, you do not specify it, you just convert the log to ln. And that represents natural log. Alright, let's go ahead and try another example. Let's say we have, for number 2, log base 1/4 of y. Alright, so we're going to write it as a common log first, and then from there we'll go into natural log. Alright, so log base 1/4 of y. We can just look at the example in number 1 and we can see what it's going to be. Okay, so it's going to be log base 10. Remember, you don't have to specify the 10 for common log of the argument, which is y, divided by log base 10, you don't specify it, of the base of your logarithm, which is 1/4. And that is the answer to question 2a. Notice we skipped this step right here. Alright, let's take a look at the B part. How do you write log base 1/4 of y as a ratio of natural logarithms? Using the change of base formula, you have the natural logarithm of the logarithmic argument y divided by the natural logarithm of the base, which is 1 over 4. And that is how you write it as a ratio of natural logs. Alright, let's try another example. What if we have a case where the base is a variable and the argument is a fraction? Question 3. What if we have log base x of 5 over 7? Alright, so what we're going to do first is write it as a common log, or log base 10. Okay, so part A is common log. We have log base x of 5 over 7. If you want to write this as a common log, you have log base 10, which you do not specify, of the logarithmic argument 5 over 7 divided by log base 10 of x. Okay, so this right here is common log. How about natural log? For natural logs, follow the same procedure. Part B, we have log base x of 5 over 7 as a ratio of natural logs. You have the natural logarithm of the logarithmic argument 5 over 7 divided by the natural log of the base, which is simply x. And that, ladies and gentlemen, is your final answer. Alright, for the next set of problems, we're going to evaluate the logs using our calculator. Alright, so evaluate each log with your calculator, with a calculator. So, number 4, let's say we have log base 5 of 13. So how do we do this? Now, if you take a look at your calculator, the regular calculators that we have, for instance, I have a TI, let's see which one I have here, 84. Okay, it has just common log, log base 10, and natural log. It doesn't allow us to specify what the base is. So how are we going to be able to use a calculator to find log base 5? Well, all we'll simply do is we are going to change it into log base e or log base 10. Alright, let's do log base 10 first. So common log method. Alright, this is method 1. So for common log method, we're just going to change this log base 5 of log base 5 of 13 into base 10. Alright? So using the change of base formula, this would be log base 10 of the logarithmic argument 13 divided by log base 10, you don't specify, of the base, which is 5. Okay? So now we just simply plug this into the calculator. We are going to compute log of 13 divided by, okay, not times, divided by log of 5. And the answer is 1.5937 to 4 decimal places. Alright, you could do it this way. You can also use the natural log method. Okay, so natural log method, you will get exactly the same answer. So natural log method, this is method 2. So for natural log method, we're going to change log base 5 of 13 into natural logs, okay? So this is going to be the natural log of the logarithmic argument, which is 13, divided by the natural log of the base, which is 5. Alright? Let's plug it into our calculators and see what we get. We have the natural log of 13 divided by the natural log of 5. And our final answer is exactly the same as what we had before, 1.5937 to 4 decimal places. Alright, let's try another example. I'm going to just use one of the methods now, okay? So for question 5, let's say we want to evaluate log base 1/4 of 3. So for this one, I'm going to use the common log method. Okay? So to find out what this is, to evaluate this using the calculator, log base 1/4 of 3 is going to be log base 10 of 3 divided by log base 10 of 1/4. Okay? So we just put that into the calculator and get what the answer is. So we have log of 3 divided by log of 1/4, or 0.25. And your answer is negative 0.7925 to 4 decimal places. Alright, so this is approximately negative 0.7925. Alright, so we're done with some examples on change of base. Now let's take a look at how to rewrite log expressions. So the instructions are for us to rewrite using the natural logarithm of 2 and the natural logarithm of 3. So the next problem we have, this is number 6. So for question 6, what if we have 6a, the natural logarithm of 12? So how can we rewrite this using log 2, natural logarithm of 2, and natural logarithm of 3? So all we just have to do is rewrite the logarithmic argument 12 as powers of 2 and 3. Okay, so let's write that down. So the task is to rewrite the log argument 12 as powers of 3 and 2. Okay, basically 3 raised to some power times 2 raised to some power. Okay, so that's the goal. We want to write it as 3 raised to some power, let's say x, times 2 raised to some power y. To accomplish that, we'll have to decompose 12 completely. So let's go ahead and do that. So 12, 2 goes into 12 6 times, 2 goes into 6 3 times. So the prime factor decomposition of 12 is 2 times 2, which is 2 squared, times 3 to the first power. Okay, so what does that tell us? It helps us to see that the natural logarithm of 12 is equal to the is equal to the natural logarithm of 12 is equal to the natural logarithm of 2 squared times 3. Okay? Now using the properties of logarithms, remember when you have the product of numbers, it has the same thing as the sum of the log of the sum of the factors. Okay? So this is going to simply become the natural logarithm of 2 squared. So this times becomes a plus. Okay? And then we're going to take the log of 2 squared plus the natural logarithm of 3. Okay? And then using the power property of logarithm, we can power down this exponent. Okay? And our final answer is going to be, let's write down our final answer. Our final answer is going to be 2 times the natural logarithm of 2 plus 3. And that's how you can rewrite natural logarithm of 12 using natural logarithm of 2 and natural logarithm of 3. Alright, let's try one more example. Now let's say we have, so that's number 6. So number 7. Let's say we have the natural logarithm of 3 root 2. How do we do something like this? So the goal again is to write this as a natural logarithm of 2 and natural logarithm of 3. So what we're going to do is rewrite this, specify that, rewrite um, 3 root 2 as powers of 3 and 2. Just like before, right? So 3 to the x times 2 to some power y. Alright, so how do we do that? So 3 root 2 can be written as what? 3 doesn't have any power, so it's just 3. How do you write root 2 as a power? Root 2 is the same thing as 1/2 power, okay? So the natural logarithm of 3 root 2 is the same thing as the natural logarithm of 3 times 2 to the 1/2 power. Now, applying the product property of logarithms, this can be written as the natural logarithm of 3. This plus times product of numbers becomes the sum of the logs, okay? Plus, this times becomes plus the natural logarithm of 2 to the 1/2. And then what we're going to do next is power down this exponent here, which is 1/2. So you power that down. And that leaves us with our final answer, which is the natural logarithm of 3 plus 1/2 the natural logarithm of 2. And that, ladies and gentlemen, is the way of rewriting ln 3 root 2 using ln 3 and 2. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of log, do give us a thumbs up. We appreciate your positive feedback. And don't forget to subscribe to our channel. If you have questions or comments, just post it in the comment section below. More tools can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.